Hi everyone, this video is for e-learners and I will be explaining the final project. So when you're in your Polaris course, you want to click on Marking Period 4, Week 7, and if you scroll down, you'll find the Trig project folder. Go ahead and click on that. So we're going to start off by looking at let's look at the final project guidelines. All right, so when you're doing your project, I'll also click on this here, the assignment that you need to turn in. So what you turn in is number 1, this final project worksheet filled out. So you'll need to type maybe in a different color. I think there are some websites where you can write on a Google document. You can try doing that for the math work. Just make sure for the math you show every step. So if you need to, you can use this insert equation tool to make exponents or square roots. And then you'll fill in this part and then this part down here. And then the rubric is what I will fill out. So you don't fill out the rubric. So you'll complete that. You will also be organizing all of your work into a Google slideshow. So you'll also attach your Google slideshow to this assignment. And then finally, for your presentation part of it, so the presentation part is worth 5 points. You will do instead of presenting to the class for e-learners, you'll make a screencastify or some other video recording device. I don't need to see your face in it. If you want to include it, you can, but I just need to see your screen and then hear you talking, kind of like the screencastifies that I do. All right, so that's what you need to submit. So 3 things in here: the worksheet, the Google slideshow, and then the presentation, the video. Wait, my product folder. Okay, so let's look at the final project guidelines. So this is going to be 55 points. It's due on Tuesday, May 18th. You'll have 4 days to work on it in class, which is Wednesday, Thursday, Friday, and Monday. And then note the late project deduction points each day. So you need to submit it by Tuesday at 2:50. And then the purpose is to basically connect the concepts from Algebra 1 to geometry and help better prepare you for some of the more challenging concepts in geometry that use trig and Pythagorean theorem. Because next year you'll be using Pythagorean theorem all year long. So it's a big part of geometry, and also working in the coordinate plane with algebra and geometry combined. All right, so the first thing you're going to do is create a right triangle from 3 linear equations. So if you want to make a right triangle, then one of the angles has to be a right angle, which means that 2 of the lines have to be perpendicular. To be perpendicular, that means that the slopes will be opposite reciprocals of each other. So if you look at my example, you go back to here, the one I chose, you can't use what I chose, and actually I have other restrictions for what you can't use. The slopes that I chose are 2 and -1/2. And then the other equation doesn't really matter. I wouldn't make it anything too crazy, just enough to make a right triangle. So see how the 2 and -1/2 are opposite reciprocals of each other. So if you look in the final project e-learner guidelines, these are just things that I might tell in class, but that are not on the regular guidelines because I told them in class. So for your equations, you cannot use a slope of 1/2 and -2, -1/2 and 2, or 1 and -1, and then or 0. So you can't have horizontal or vertical lines because that's too easy. And then here's the due date again. And then these are all things that I mentioned. For your project, you guys can work it with yourself or with one other person. So, and then here's the schedule of what you should be doing each day. So I kind of organized it to make sure that you stay on track. All right, so going back to the guidelines, let's see. You will need to restrict the domains of each line so that only the triangles show up. So when you make the 3 lines, you're going to have lines and then they'll make a triangle, but you have to make just the triangle. So look at how I restricted the domains. The first thing to do is to figure out your points, A, B, and C, by just clicking on the intersection of the lines. And then once you find those, you can use those to restrict the domains for each line. So I know that this equation goes from this is 0.8, and that's 4. So you're using the x coordinates to restrict the domain. So make sure you do that and label A has to be the right angle. I did specify that here. So you must label your vertices A, B, and C with A as the right angle. And then the triangle also has to be scalene. So you can't have two legs that are congruent to each other. And then when your graph is finished, and if you do get that, then I would change the equation that's the hypotenuse, like make the slope a little bit different, and that should help you with that part. When your graph is finished and the window shows the triangle clearly like this, so you have the triangle, your equations, your labels, your name, take a screenshot of that and then put it in your slideshow. Go ahead and feel free to use the formatting that I do here, but maybe don't make it look exactly the same, put your own touch on it, but you can use that for organizing your work. And then find the triangle side lengths is the next part. So remember what we learned about how to find side length. So if you've got a side here, you can make a little right triangle, go up and over. So if this is 2 point whatever, and this is, what is this, 9 point whatever, you would subtract these two numbers to get your y variable, your y difference in the y, and then do the same thing to get the difference of the x, and then do a squared plus b squared equals c squared, and use the Pythagorean theorem to solve for c. So you do that for each of those. So that also is, you'll do the work for that in the final project worksheet in these boxes. So finding the length of each side. So the part 2 corresponds to part 2 in the guidelines on the worksheet. So you'll show the work for that here when you put A, B, and C, and then do Pythagorean theorem. Okay, so show all work, round your answers to 2 decimal places, and each partner should have their own worksheet so that everyone's participating and doing the work. Okay, display your answers on the next page of your PowerPoint. You don't need to include your work in the PowerPoint, just put it in the worksheet. All right, and then next you're using trigonometry, so use the trig ratios, sine, cosine, and tangent to find, or for angle A and or B and C. All right, I don't know how this eraser is supposed to work, but whatever. Okay, so notice here I'm just doing the fractions, and then I find the decimal, round to 2 decimal places. And then I show that sine of B is cosine of C, 0.63, and then these two are the same, and these two are the reciprocals of each other. So that's what I mean, tangent of B equals 1 over tangent of C. Okay, and then you will do inverse functions to take the inverse of one of those to find the measure of angle B, subtract it from 90 to find the measure of angle C. And then there's a bonus question if you want to take a look at that. So create a quadratic equation that passes through 2 vertices of your triangle. Okay, so that's pretty much it. And then remember that on here, I have the different things you should do each day. So kind of like a checklist for what you should do, and make sure that you're keeping up with it, and definitely not waiting till the last minute to do these things. So you should really have all of this done by Tuesday at the beginning of the day, and then just turn it in by the end of the day. Okay, so if you have any other questions about this, feel free to send me an email and I will respond to you. But everything is there. If you need any help, like I said, just send me an email and we'll figure it out. Okay, so thanks for watching. Have a great day.